Welcome to aminacademy.com. In electrical engineering, let us discuss about types of capacitors. First, we will discuss about spherical capacitor. A spherical capacitor consists of solid or halo spherical conductor surrounded by another halo concentric spherical of different radius. Here, outer shell is the inner shell, radius of inner shell is small r, outer shell is capital R. Now, when outer here, when outer shell is earthed, what happened? We can explain here. When which means like here, consider a spherical capacitor consists of two concentric pairs of radius R and R meters as shown in figure. Suppose the inner sphere is given the charge of positive Q coulombs. It will induce a charge of negative Q coulombs on the inner surface which will go to earth. Then if the dielectric medium between the two spheres has relative permittivity of ER, epsilon R, then the free surface potential of the inner sphere due to its own charge equal first free surface, that means was relative permittivity is epsilon R, then the free surface potential equal Q over 4 pi epsilon 0 epsilon R into R, because radius of inner sphere. The potential of the inner sphere due to minus Q charge is negative Q charge is minus Q over 4 pi epsilon 0 epsilon R capital R. Now total potential difference, total PD potential difference is equal Q over 4 pi epsilon 0 epsilon R minus Q over 4 pi epsilon 0 epsilon R capital R. Now taking a common factors, Q over 4 pi epsilon 0 epsilon R 1 over R minus 1 over R. Further, it is equal Q over 4 pi epsilon 0 epsilon R, taking an LCM, R minus R. This much farad. When next condition, when inner sphere is earthed, when outer sphere is earthed, this is the expression. When inner sphere is earthed, such a capacitor is, then if the charge of positive q coulombs is given to the outer sphere A, it will distribute itself over both its inner and outer surfaces. Some charges q2 coulombs will remain on the outer surface of A because it is surrounded by F all around. Therefore, the total charge Q equal to Q1 plus Q2. Therefore, C1 4 pi epsilon 0 epsilon R minus R this is C1, like C2 and C2 is 4 pi epsilon 0 epsilon R B, that is R, capital R. Then therefore the total capacitance is equal C1 plus C2. We have to get it C1 and C2, then apply the sum. Next, parallel plate capacitor. A parallel plate capacitor are the type of capacitors which that have an arrangement of electrodes and insulating materials, that is dielectric inside. The two conducting plates act as electrodes. There is a dielectric between them. This act as a separator for the plates. Look at here, two conducting plates having charges positive Q and negative Q. In between, dielectric material is filled. Then that is electric field E. Then that separation of distance is D. Between the plate separation is D meter. Now, a parallel plate capacitor consists of two plates here parallelly assembled and with a meter square, separated by the thickness D between a medium. A relativity permittive epsilon R is given. If a charge positive q coulomb is given a plate, first plate, then flux passing through the medium is q coulombs. Flux density in the medium is, then flux density V equal psi over A, which is equal Q over A. Then now D equal epsilon E, and E is over D, and E equal V over D. Then substitute both, then we can get it Q over A is equal epsilon V over D. Therefore, we can say Q over V equal epsilon A over D. This is the result. Now C equal, capacitance C equal epsilon 0 epsilon R A over D farad. This is one medium. The same is equal epsilon 0 epsilon R equal to 1 because it is a now air medium. Farad for air. Next one, medium partly air. Suppose if the medium consists partly of air and partly of parallel-sided dielectric slab of thickness T, then relative permittivity epsilon r, the electric flux density is equal to partly air and partly medium. For that cases, Q over V equal epsilon 0 A over D minus T minus Q over epsilon r, where T is the thickness of air medium. Or C equal epsilon 0 A over D minus T minus Q over epsilon r. If the medium were totally air, then capacitance would have the same D. Here, partly medium, partly air. The dielectric thickness is T and D is the thickness of air. Total thickness, that is total space between the plates, is D, and T is the thickness of dielectric medium. Then this formula I have to use it. Now next one, composite medium. Different mediums is parallelly fitted in between the parallel plates. Then capacitance is sigma epsilon 0 over A over sigma d over epsilon r. So by expanding this, C equal epsilon 0 parallel plate area A over T1 epsilon 0 1 first medium plus D2 second medium, D3 third medium, like it is. That means here overall capacitance of this composite medium is like here, where epsilon r1, epsilon r2, epsilon r3 are relative permeability of different mediums. Next one, composite medium we done. Then next we'll discuss about multiple and variable capacitors. Let us know something about the variable capacitors whose value alters when you vary. That means by using this, turning this knob, we'll get a different capacitance of this equipment. It's very useful for electronic circuits. Let us know something about the variable capacitors whose value alters when you vary, either electrically or mechanically. Variable capacitor is generally consist of a interwoven set of metallic plates overrun inside metallic plates in which one is fixed plates and other is variable plates. These capacitors provide the capacitance value so as to vary from 10 to 500 microfarad. That much minute farads can alter. Variable capacitor. Whenever the capacitance of a capacitor is changed based on the necessity to a certain range of values is known as variable capacitor. The two plates of these capacitors can be made with metals where one plate is fixed and the other one is movable. The range of capacitance that is provided by the capacitor can range from 10 picofarad to 500 picofarads. The symbol of this capacitor is shown below, where the arrow symbol in the image shown, that is a variable one, that is here. This capacitors, this indicates variable. Construction, the construction of variable capacitor is shown below here. Look at here, this way. About this outer plates, the inner fixed plate and movable plates are fixed, and between the air gaps can be changed by using mechanical knob. So far we discussed about different types of capacitors and its capacitance. We have done. Please subscribe our YouTube channel.